Hello everyone, welcome to this session. So in this session, we will have a case study, the banknote classification using the linear SVM. So as we all know, the paper-based money is still one of the main options in the market. So when using paper-based money, one problem is to detect if the banknote is a genuine or forged, right? So clearly there are machines to detect the counterfeit banknotes, but they are expensive. So now people are thinking of using some image-based method, right, to make it cheaper and easier. So you are the data engineer. Suppose you are the data engineer to undertake this task. So the data were extracted from images taken from the genuine and forged banknotes. Right? So then for these images, we use a called wavelet transform to extract features from these images. And the features are what? Variance, skewness, kurtosis, and entropy, right, of the transformed image. So there are two classes, the genuine or forged, right? So the total sample is 1,072 samples. So now you are asked to train a linear SVM to solve this problem. So let's see how to do that, right? So we first load the data. So this data is a CSV file. So we have covered this in the first course of this specialization, the MATLAB part. We know that how to read a CSV file outside, and we put it into a table and extract data from table, right? So this is the result. The CSV file, we have the variance, skewness, kurtosis, and entropy, and the class 0 and 1, right? So for this CSV file, I also write the comments about what these comments do, and if you don't remember it, you can watch here, right? Then we will decide the train and test set, right? So how can we do that? So for this one, CV partition, I think you're familiar with this, and we covered a lot for this function in the data preparation week, right? So this hyperlink will also show you more. So in this command, we put 75% as a training set and 25% as a test set, right? So then in each set, we do a random partition. Then we will start the training, right? So let's first use the linear SVM to see if the result is good or not. So then what the function we can write like this: x train, y train, kernel function, we use linear, and we do the standardization, right? The standardization, data preparation week, you know this, right? Yeah, so here I also write some descriptions. Then this model, the SVM classifier is trained. The next is to do the prediction, right? So prediction, we have use the test data to SVM classifier object and the X test. Then we get the Y pred. Then we calculate the accuracy. So we can see the accuracy is 97.18. So this means that the trained linear SVM is quite good. Right? So we can be used. So all of these processes are in the live script. So you can also try the other options. For example, you can use a soft margin, right? And other choices, other hyperparameters to be tuned, and you can try yourself. So, okay, that's for this case study. Thank you very much.